Hello, everyone, and welcome to Biohackers Lab. I'm your host, Gary Kerwin, and on today's episode, I have Dr. Lee No. Dr. No is a licensed naturopathic doctor based in Canada. He has held positions as medical advisor, scientific evaluator, and director of research and development for major organizations. He is the author of the new book, Mitochondria and the Future of Medicine, the key to understanding disease, chronic illness, aging, and life itself. Lee, thanks so much for coming on today.
My pleasure. Thanks for having me.
I mean, that's quite a title of a book too. So it's all about life itself. That's what we're going to get into today. That easy talking topic.
Yeah, of course it's easy.
So the first thing I want to ask you: do you think you're a mitochondriac? So have you ever come across that term?
I have, in the sense that I'm fascinated with mitochondria, and I look at everything from the perspective of mitochondria, but I've also heard of that term from the opposite end. So more in thinking of it as almost like hypochondriac, but related to the mitochondria as well. So yeah, I take the first view.
Yeah, no, and when I had a look online for a little dictionary reference, the one I found that was interesting, which you might like, is a biochemist with a chronic and unusual intense interest in mitochondria.
Okay, yeah.
I love it how they had to define unusual intense. So anyway, yeah, you've done a lot of research into these things called mitochondria. And for anyone who doesn't even know what that word means today, we're basically talking about the things that make energy in our body and keep us alive. And that's why it's going to be so interesting to find out how can we help these little things in our body so we can produce better energy, more energy, and just live a great life itself, as you mentioned. So if you could maybe start us off with and just explain to someone, what is a mitochondria?
Okay, so yeah, so I'll kind of, time travel back with everyone to their high school days where we learned about cell biology in high school biology. And basically what we learned was the cell has many different types of organelles. And the best way to look at organelles to a cell is very similar to organs are to our body. So they're distinct structures that carry out defined actions. So with just like the liver has certain actions in our body and the spleen and the lungs, well, the mitochondria for the cell, its function is to produce energy. And in fact, when you consider that, everything that happens within a cell, from the obvious, like when you look at organs or tissues, like with the muscle and you contract the muscle, I think it's pretty obvious that takes energy. But even just, the maintenance of the cytoskeleton or the transfer of ions across cell membranes, all that takes energy, and it's the mitochondria that's responsible for producing over 90% of that energy. So when you look at the importance of the mitochondria within a cell, when you consider everything that happens in a cell requires energy, you can see that when mitochondria don't function well, everything else starts to fall apart.
Mm-hmm. So you've already touched on how important these things are because they're making 90% of our energy. So what I did hear in another talk you gave that you said there's three sources of energy that the body uses, is it?
Right. Yeah. So three phases. So the first phase is what we call glycolysis, and that actually doesn't even happen within the mitochondria. So that is the where say 10% of the energy within a cell is produced. But out of glycolysis, the end products then get transferred into the mitochondria, where it participates in the next two phases of energy production. So the next phase after glycolysis happens in the innermost part of the mitochondria called the matrix. And this is where Krebs cycle occurs. I think we all learned it as the Krebs cycle. More recently, it's been called the tricarboxylic acid cycle, or TCA. And then out of that cycle come other molecules that get fed into the last phase of energy production called the electron transport chain. And this is where the energy from those molecules get transferred and used to pump hydrogen ions across cell membranes. And then to make a long story short, those hydrogen ions flow back through a channel to create energy.
Okay, so it's quite in depth there. But Did you? I don't know. I don't think you mentioned the little molecule ATP also there. Did you? And is that
No, I
in that
didn't.
second? Is that in the second phase?
That's in the third phase.
Okay.
So that is So when we talk about energy at the cellular level, we're essentially talking about ATP, or adenosine triphosphate. So basically, an adenosine molecule with 3 phosphates attached to it.
Okay. Yeah.
So,
Because that's always if anyone listens to people talking about energy, it's ATP energy, and how do you boost that in your body? Because that's really what we're talking about here, is that there's these little organs in a cell that make energy, and that energy is what keeps us alive. So anything we can do to help make more ATP is not a bad thing.
Right.
Yeah. Okay. And I love it that you brought up electrons already, because just to sort of, this is something we'll get onto later in the discussion, but this is like grounding, and people might already understand electrons maybe basically from that point where they go, oh, so I know if I take my shoes and socks off, touch the ground with my bare feet, changing electrons with the earth. And you're saying here how important those are at a cellular level.
Yes.
Yeah. So
So this is where it gets really interesting, though, and a little bit more nuanced as well, because when you look at the electrons in the mitochondria, they can have very significant benefits. Of course, that is what is transferred from one complex to the next in the electron transport chain to create energy. So we absolutely need those electrons. But they can also kind of spill out of the electron transport chain prematurely. And that's when things start to go wrong, because those electrons then create free radicals, which are not always bad, I should mention. I think a lot of times we think of free radicals as a bad thing. But in some cases, free radicals can be a good thing. But depending on the background context of when and where these free radicals are produced, they can be a bad thing. And when we're talking about free radicals spilling out of the electron transport chain, often they do create those harmful free radicals.
Okay.
So that's something that we need to be aware of.
Yeah, and so that gets me thinking too, because we're talking also about like a spectrum of mitochondrial dysfunction here, which could be very mild, or it could be very severe. And the severe cases tend to make news headlines of poor children born with issues, and then they only survive a very short period of time. Would you mind just maybe briefly explain to people like that spectrum, like what is mild versus an example of an extreme case of mitochondrial dysfunction?
Sure. Yeah. So on the mild end, we're all born with, we're hopefully all born with healthy functioning mitochondria. And this is separate from those that are born with genetic mitochondrial disease, I should mention, where you're born with kind of defective mitochondria. And that's at the other end of the spectrum.
Mm-hmm.
But when we're born, we typically had, well-functioning mitochondria. But there are differences from one person to the next. And some might already have a few genetic defects, but not enough to impact the level of energy that's produced. In those situations, it might not take a lot of insult from environmental toxins, as an example, to cross that threshold where we now have a problem with energy production. And in some cases, that is not only very slow in its progression, but sometimes a lot of times people might not even know that they have this. So a good example, and I mentioned this in my book, is that some people might grow up thinking, they just never had that endurance to be good at sports, but they typically live a normal, healthy life otherwise. But then you get the full range of the spectrum all the way to the other extreme, like I said, especially when we're looking at mitochondrial disease. And in extreme cases, these are children that are born with very dysfunctional mitochondria. They don't produce enough energy, and they often have a very short lifespan, often with all sorts of different health conditions. And unfortunately, many times they develop early cancer as well.
Mm-hmm. So I guess for us, we're not going to go into the end range of the severe spectrum. This is going to be the everyday person like you and me, and how we can sort of hack our mitochondria. So how can we optimize these little guys so that we feel full of energy?
Mm-hmm.
So for me there, what I like to think of then to maybe try help people to understand is what you touched on it already a little bit with environment. What would you say are some other common causes that would deplete the ability of these mitochondria to work well?
Okay, yeah. So I did mention environmental toxins, and I should mention there are many. Some are easier to avoid than others, but a number of different pesticides, as an example, have been shown to damage the functioning of mitochondria. A whole host of different pharmaceutical drugs have also been shown to damage the health of mitochondria, and the ones that I particularly point out is that antibiotics, especially certain classes of antibiotics, have a fairly strong negative impact to mitochondria. But then there's the statin medications, which are the number one prescribed class of drugs in the world. And these are used to lower cholesterol, but they've also been shown to deplete a key component of the electron transport chain. So, of course, you deplete that, you're not going to be able to produce energy. There are artificial food colors that have been linked to dysfunctional mitochondria. But the thing that is probably most relevant to the general population is when you have an imbalance of supply versus demand. So, and this is one of the reasons why things like overeating and being sedentary have been linked to so many different degenerative health conditions. So let's just talk about oversupply to start. Mm-hmm. So this is a situation where you're eating too much. So you're eating too much, and you have too much supply for the demand. So even and this is, mind you, I'm not just talking about sedentary individuals here. I'm talking about, you could be physically fit, but if you're consuming far too many calories, so to speak, for what you actually need, what ends up happening is all those calories that you consume get digested, and all those molecules get transferred to all the cells, and then broken down in the cells, goes through glycolysis and the TCA cycle, and then those molecules start to enter the electron transport chain as electrons. So basically, every time you eat something, you're essentially going to break it down into electrons. And the problem is like I said, when you have those electrons going through the electron transport chain, that's fine. But you really want those electrons to get to the end, which is complex 4. So maybe just backtrack a little bit again. We have complex 1 and complex 2, and both are the start of the electron transport chain. They pass their electrons off to coenzyme Q10, and then over to complex 3, then to cytochrome C. I hope I'm not getting too complex here. And then finally, complex 4. Now, complex 4 is a unique spot in the electron transport chain, because that is the only area in the body where we can take those electrons, enzymatically react them with oxygen to create water. What happens in a situation, though, where those electrons don't end up reaching complex 4, they spill out of the electron transport chain and prematurely react with oxygen and create a superoxide free radical. So, like I said, I don't want to give you the impression that's always bad, but in the context of overeating, because we have to put this into context of what else is happening. And if you have too much supply versus demand, those superoxide free radicals are typically going to be seen as a bad thing in the cell and go on to inflict damage. So that's one of the reasons why we really want to make sure that we're not going to overconsume food when our bodies don't actually need all that energy.
So I'm just trying to think, how would someone know they're over-consuming food, would you say? So because you did mention you could be fit, but you could be consuming too many calories or too much food too. So yeah. I guess there you would wonder, like, you would use your body as a sign to say, no, but I look physically fit. But now, how would I? Do you have a reference? How would you?
Yeah, and this is it's very difficult to answer that question. Now, it can be answered, but it involves being in a laboratory setting, looking at your metabolism, all that stuff, which is pretty much out of the question for the general population. So the take home point for this is really just monitor your food consumption and try not to overeat, whatever that means for a particular individual. That, it's going to vary depending on the individual, but the idea is to kind of be mindful of overconsumption. I wish I had a better answer for you, but at this time, the technology really only exists in the lab. So, yeah.
And that's also got me thinking, because, intermittent fasting or fasting protocols have become so more mainstream or popular recently. Mm-hmm. Would you say from a mitochondria point of view that fasting or intermittent fasting is a good thing?
Yes, yeah. So there is actually some good research to show that, or emerging research that shows intermittent fasting, does have benefits to the mitochondria, and not just intermittent fasting, and that's an easier way to do something else called calorie restriction, where you are dramatically reducing the number of calories you eat. And what's interesting is calorie restriction is considered the best way, the most consistent way when you look across all different species that have been studied to extend lifespan. And what's interesting is that according to the newest research, it's actually the mitochondria and its functioning that determines our lifespan. So when you kind of pull all the different pieces together, you can see that, consuming less calories is probably a better thing for your health and longevity. But intermittent fasting is definitely a way to go about it in a way that is probably a little bit more manageable. So, and that also brings up the other point. A lot of times people eat a late night snack, just before we're going to lay down and have pretty much no energy demand for the next 8 hours or so. That is one of the reasons why, late night snacks is, and I'm simplifying here, but one of the reasons why it's probably not a good idea to eat those snacks so late at night when you're not going to be expending those energy, that energy and electrons.
Okay, that's good to know. Also, I don't know if you've ever seen this thing, but this is an Oura ring that measures your sleep. And
nice.
And it also tells you, like, hey, did you eat something a bit late? Because it can see when your heart rate occurred, in the cycle.
Oh, cool.
And so I'm just already thinking here, it's like, I also had another circadian biologist on, and she said the exact same thing. Like, if you eat too late, it affects your skin's ability the next day to protect itself from the sun if you did it chronically. But I'm just thinking, and now you're just highlighting again, don't eat too late because it's not so great for your mitochondria in the long term.
Right.
Yeah, so there's so many benefits here that I'm just trying to help sort of key different points for people to hear, to understand.
Yeah.
So you mentioned the oversupply, and then there was the other side of it, over demand, was it?
Yeah. So we talked about too much supply, but also not enough demand for the energy that you produce. So this is where being sedentary comes into play. So again, we know being sedentary, a sedentary lifestyle has been linked to all sorts of different degenerative diseases. But when you look at the mitochondria, it's an easy way to explain it, because again, when we are, all those electrons that we consume are going through the electron transport chain, producing energy in the form of ATP. Well, what ends up happening is when we produce ATP, it's produced from its building blocks of ADP, which is adenosine diphosphate, so an adenosine molecule with 2 phosphates, and then it takes a 3rd phosphate and attaches it to create ATP. So you can see that the building blocks is ADP. The only way to get ADP again is to actually use up ATP. So when our bodies use that energy, it actually breaks off that 3rd phosphate, recreates the ADP and phosphate, which then gets cycled back. So it's just a continuous cycle. The problem is if we're sedentary and we're not using up that ATP, we're not generating the precursor or the building blocks. So their ADP comes in short supply. So what happens then is that the structure in the cell that creates ATP, it's called ATP synthase. Without the building blocks necessary for it to function, it slows down, or in the worst case scenario, shuts down. And what happens then is that there's a backlog all the way down the electron transport chain. So the electrons stop flowing through the electron transport chain. And what ends up happening, though, is that there are more electrons that want to enter but have nowhere to go. So those electrons spill out, again, prematurely react with oxygen to create superoxide free radicals. And that is one of the reasons why it's extremely important to make sure that you're physically active. You're constantly using up that ATP so that you can regenerate the pool of ADP that's needed to keep make sure that structure that produces ATP is continuing to run smoothly.
So that's just incredible stuff for people to, we're always told you've got to just keep moving. Movement is health. You don't have to. I had Ben Greenfield on, and he said, there's a difference between exercise and moving. Like we should all be moving, and then exercise is just a different intensity, which is true. Mm-hmm. And what I'm getting from you here is that, this is another important aspect to just generalize movement, fidgeting, keep busy, because then you're able to get these ADPs, these foundations to then make more ATP again, so more energy again. So we need to sort of be moving around. And would you say that's actually one of the, because I want to get on to how you would optimize some of your mitochondria. And so the first thing here is just general movement. That's enough to get this ADP. You don't have to do like high intensity exercise or run a marathon or something like that.
No, not at all. Yeah, you're right. It's just really just get moving. That's the most important thing. Of course, if you can increase the intensity, there are other benefits, and we can get to that. But just in terms of using up that ATP that's been generated, just movement is all that's needed. And I've heard the catchphrase "movement is medicine," and that's exactly it. There are enough studies now that link sitting. The length of time you sit in a day is directly correlated with your risk of various health conditions. So even if you're a fit, athletic person that undertakes, strenuous physical activity, the length of time you sit is still an independent risk factor. So, the idea is to just move all day if you can.
Yeah. Well, I've always dreamt, I haven't set up my own desk that way, I should really, but I've always dreamt of like fidget desks. So you could sort of work at your laptop or your computer, but you're generating just subtle movement all the time. Right. In some way or another. So, but you don't have to chronically stand or chronically sit. You just get to fidget like humans do. We fidget. So
yeah, that's a good idea, actually.
So I'm just thinking now, okay, great. So movement is key, but you did already touch on that. We could take it for any serious people here. We could take it another level to actually grow more mitochondria, from what I understand, through exercise.
Mm-hmm. And this is where the real benefits come from. And before I go any further, I want to emphasize that, what I'm about to talk about is probably the single greatest thing for mitochondrial health. We can talk about, reducing our exposure to environmental toxins. We can talk about nutritional therapies that support the health of mitochondria, things like that. But when you look at all the evidence to this point, the single greatest thing, if you have to choose one thing to do for the health of your mitochondria, it's moderate intensity physical activity. And this is because, like you said, it generates more mitochondria. So what this means, and I'll try to explain this without getting too technical, is that when we exercise, we create a certain level of energetic demand on our cells, and as long as we don't overdo it, there is the cells go under a healthy stress, and as a result, creates more mitochondria. It thinks, I don't have enough energy to meet the demand of this particular level of physical activity, and the body adapts by producing more mitochondria. The great thing about this, and one of the reasons why what we call mitochondrial biogenesis is so important, is that now you have more mitochondria producing more ATP. So the next time you go out and do exercise again, you now have greater mitochondria to meet that demand. And you continue to kind of slowly increase the intensity, just continuing to divide those mitochondria and create more mitochondria and energy in the cell. But the important thing is is that at rest, which is the vast majority of the day, even for elite athletes, at rest, that metabolic demand is now divided up amongst many more mitochondria. So each individual mitochondria is under considerably less stress and therefore producing a lot less of those damaging free radicals. So, you put that into context over a lifespan, you're seeing tremendous health benefits in those individuals that undertake an exercise program versus those that don't. And really, and again, I'm simplifying here, but that is essentially how it works, is that you're creating more mitochondria and dividing that load, that stress amongst all those mitochondria, as opposed to all that load on just a few mitochondria that's, going to have to work overtime and break down eventually.
Yeah, I like that. I didn't quite realize. So you're making more of these like worker bees, these workers that can take the load of the system versus only dumping all the stress onto a couple of people and burning them out.
Right.
And so that's why exercise makes more of these workers, which we need.
Yes.
Yeah. And can we lose some of those workers by going more sedentary? Does the reverse happen?
It absolutely does, yeah. And that's the incredible thing with our bodies. It's always adapting, and unfortunately, it's going to adapt to a sedentary lifestyle as well. So if you're sedentary, your body gets a signal that, hey, you know what? I have all this extra mitochondria laying around, and I don't even really need that. So what's going to end up happening is that over time, and this happens over the course of a few weeks, our cells you'll start to notice that our cells have fewer and fewer mitochondria. So again, not just physical activity and being active is important, but making sure that you're doing that on a consistent basis so you don't have that negative adaptation.
Okay. And so it's just got you. I love this because people get me thinking of different things. And you got me thinking about how, we're told exercise is so important for cardiovascular health. But now I'm thinking, it's because your heart and your brain are two of the biggest areas where we have most of the mitochondria. That's right.
That's right, yeah.
And so I'm just thinking here, so that's another reason why moderate exercise is good for our heart, because does it mean that we make more mitochondria in our heart through exercise, do you think?
We do, yes.
And we make more mitochondria in our brain potentially by
Absolutely.
exercise?
Yeah. And that's a cool thing. And that's one of the things that connects the brain and the heart. It is our adaptation at the mitochondrial level. And so one of the things that you'll see is that a lot of times you look at the health benefits of physical activity to the heart. Anytime you see a study that shows benefit to the heart, you can almost always translate that or extrapolate those results to the brain, because we're starting to see that when you look at energy intense organs like the brain and the heart, they're going to have the same adaptations. And so when you exercise, it's going to benefit everything.
Yeah, so it's not just a blood flow thing. There's other elements to the health spectrum here.
Yeah. Well, of course, there is an element to blood flow. And then the important thing with blood flow is that it carries that oxygen and those nutrients to the cell so that we can feed our mitochondria. So, of course, blood flow is absolutely critical. But even if you go a couple levels deeper, there is that link at the level of the mitochondria.
Wow. And just a quick question whilst we're talking about blood. Is it correct that red blood cells don't have mitochondria? Are they the only cell in the body that doesn't?
Yeah, and this is what I came across in my research, is that there are, pretty much every cell in the body contains mitochondria. And mind you, we should also point out that the number of mitochondria in any particular cell or tissue is really dictated by the energetic demand. So when we talk about things like the brain and the heart, which are very intense metabolic organs, we might expect to see a couple thousand mitochondria per cell. But what I came across that I found really interesting was that red blood cells contain few, if any, mitochondria, and I couldn't really figure out why. I mean, it still has metabolic demands that it needs to meet, but I guess it's so metabolically inactive, so to speak, even though there is a little bit of energy demand there, that it probably is able to meet those energetic demands through, just simple glycolysis. I'm guessing, but yeah, it's an interesting thing that I came across that I never really got to the bottom of why these red blood cells really don't have mitochondria.
Yeah, especially when they're like the basis of life, and our red blood cells, we need them too.
Yeah.
So it's kind of weird. Like, yes, why do the things that also keep us alive not have the things that we need as the base of life?
Mm-hmm.
Yeah. So if we probably move on from exercise now, when it comes to diets, do you have a preference of diets, or do you see benefits for different kinds of diets? Because, people eat in such a variety of ways. And a lot of listeners to the Biohackers Lab podcast, they've probably been exposed to, or they're practicing things like ketogenic diet, low carb diets, carnivore diets, one of the latest ones. I just wondered, do you have any thoughts or feelings about how your diet might negatively or positively influence your mitochondria, your energy production?
Yeah, so I think there are a number of different diets that are beneficial to the mitochondria, but I think it really depends on your particular situation. And as an example, if you're looking for life extension and to reduce the risk of age-related degenerative diseases, it would appear that something like calorie restriction would be the way to go. But if you're looking at, improving the symptoms of Alzheimer's, as an example, where, we have known energetic deficiencies in the brain, something like a ketogenic diet, a nutritional ketogenic diet would be the better approach. So it really depends on the individual. And it's very difficult to generalize any one particular diet over another. Because I think that the ideal diet will depend on your own situation and what you're trying to achieve. But yeah, I mean, all those diets that you just mentioned do have a place for certain individuals.
And we discussed it before we started recording too, about the concept of N equals 1, and we are all individuals at the end of the day too. And I know you had you said some good points about you as you've done all the research, you've read all the papers, and they've done big studies on lots of different peoples and generalized results. But at the end of the day, we need to make a decision on the person. So we try to take all this information in the world, but we have to try and make a clinical decision about this person who's in front of us right now.
Absolutely.
And that's exactly what you're saying. Even when it comes to diet, it's very individual to the person.
Yeah. And I'll give you the example with my son. And this is not necessarily related to mitochondria, but just an illustration of that N equals 1, because we found out early on in my son's life, my older son, that he's sensitive to artificial food colors. So when he has artificial food colors, he becomes very hyperactive. And I guess this has been reported enough by parents that there was actually a study, and I think they called it the Southampton study. And they looked at what they called the Southampton colors. So it was the reds, oranges, and yellows. And what they found was they gave, this big population of children these artificial food dyes, and did a statistical analysis on it, and then came to the conclusion that there's no correlation between the intake of artificial food colors and the symptoms of hyperactivity. But again, that is looking at a population and taking a statistical average, so to speak. But if you were to ask me or any other parent that has a kid that is sensitive, for 100% sure that study is not representative of your child. So it's important. And so, I might go to a health practitioner that read this study and say, oh, no, your son can eat artificial food colors. There's no problem with that. Look, this study says so. But that is not telling you the truth at an individual level. It's just telling you what is happening at a population level. So absolutely, to kind of reinforce what you're saying, we really need to be able to take those big studies and take the learnings from that, but we also need to be mindful, especially in clinical practice and for practitioners, to ensure that we're delivering healthcare that's suitable for that particular individual.
Mm-hmm. And what I'd like to also then look at is, have you ever looked at psychology or social interaction and what it does to mitochondria? Did you come across any papers that looked at people who practiced laughter therapy and did it boost their mitochondria, or people who were lonely and they noticed that negatively affected their ATP production, or some link there?
Admittedly, I have not, but I would not have any doubt that there is some sort of link. Now, when you look at what impacts mitochondria, it seems like it's right across the board. So even though I haven't come across any studies that fell on my radar, it's not to say that those studies don't exist, or not to say that if those studies were done to be done, that we wouldn't see some sort of a relationship. But yeah, to my knowledge, at least according to what I've researched, I haven't come across it. But it would definitely be something to look into, because I absolutely believe that has, your cognition, your mental state, your emotional state has a tremendous impact to all areas of your life, and that shouldn't be any different with the mitochondria.
Yeah, I always when I look at someone, sometimes I just think of them as like a battery cell. And so are they like at the red level because they're not fully charged up today, or are they full green bar today? But the one thing I did find that I used to call it goosebump music. So if you like, I don't know, if you could probably think of a song that gives you goosebumps, or just like you have to sing it in the car, it just makes you feel so good.
Yeah.
And you kind of wonder, you could be having a terrible day and you're feeling so low in energy, and you put that song on and you're a completely different person like 5 minutes later.
Right.
And I'm just wondering, from an ATP or mitochondria function, is it just that these little cells go, hey, that's cool, let's make more of this stuff now? Or, yeah. But I guess no one's really looked too deep into that.
Yeah, that would be an interesting study. Yeah. To see how music impacts mitochondria.
Yeah. Could we look at environmental stuff? So you've mentioned, you did touch on it a little bit earlier, but one guest I did have on before on the podcast was talking about EMFs. So that's also a biggish topic, cellular towers and other Wi-Fi and other things. Do you believe they have any impact at a cellular level?
They do, yeah. I don't recall the exact studies or what they concluded, but it is something that I came across. Now, it didn't make it into my book, and one of the things that I'll mention is that there's so much. I mean, I could, I could continue to be researching right now. They're just so let me backtrack. The amount of studies coming out on the mitochondria is incredible. So I started this process back around 2010, I would say, really starting to look into mitochondria. And at that time, I went to PubMed. Do you know what PubMed is?
I've been there lots of times, yeah.
Yeah. So I'm not sure if your audience knows, but it's an online database.
PubMed.com with all the science research in the world.
Exactly. So you can go in and set up a search criteria, and what it does is, and I set it up so that it would send me a weekly email anytime any new article was indexed to that database that had anything to do with mitochondria. And since around 2010, and I would say it was going on long before that, but ever since 2010, these emails would come to me on a weekly basis, and it was listing, I'd say on average, about 300 new articles or publications related to the mitochondria per week. Now, mind you, that a lot of it's not necessarily clinical trials. Actually, very few clinical trials, but and there are others that have very little relevance to the mitochondria. But in some way, shape, or form, it was linked to the mitochondria, and that was on average 300 publications every week for the last 8 years. So there is an incredible amount of research going on. And, I had to draw the line in the sand at some point and start writing the book. But yes, I did come across, a number of publications with respect to electromagnetic fields and other, things like that, where our modern lifestyle has been shown to have some negative impacts.
And so earthing, are you a fan of earthing?
I am, yes. Yeah.
Okay. Yeah, because we did touch on that earlier, saying that if you actually touch the earth, that you do that electron transfer system.
Yeah. Yeah, I mean, I try to make sure that we're touching the ground. Obviously, where I am right now in Canada, it's it's impossible. It's snow outside, but in the summer we try to walk bare feet as often as possible.
Okay, so that's
Yeah,
I'm just thinking for actionable tips that people can do to boost their mitochondria, and earthing is a simple, actionable tip too.
mm-hmm.
That
Yeah.
someone could do. Your favorite topic to get into the last bit of your time with me, but supplements. Could you just maybe mention? I think I know what your favorite supplement is that you would recommend, and then if you could mention some others that people could look at taking to help boost their mitochondria.
Sure. Well, I guess my question to you then is, what do you think is my favorite?
I have a sneaky suspicion it starts with a C, and it's got a number in it.
Yes. Yeah. Well, that is definitely up there. Yeah. So I would say that is either the top or one of the two top.
Okay.
So coenzyme Q10, of course, right?
Yeah.
Yeah. So this is really cool because coenzyme Q10, for those that don't know, is what we call a vitamin-like nutrient. And it's not officially classified as a vitamin because our bodies actually produce what we need. But we do get some from food and then, of course, supplements. The interesting thing here, though, is the older we get, the more vitamin-like it becomes, because what ends up happening is our bodies start to turn down the production of CoQ10. And so as we age, so the older we get, the more important external sources become. And I theorize it's probably one of one of the things that your body can do to kind of slow down our lives. Start making things start to fall apart after our reproductive years. We're beyond our reproductive years. Most likely we've had kids, and now it's time for us to kind of make our exit and free up resources for the next generation. And I think, and of course this is just my theory, is biology or nature has kind of built in this automatic turn down of CoQ10 production, because when you look at the electron transport chain, and I mentioned complex 1 and complex 2 are basically the two starting points of the electron transport chain. They both pass their electrons off to coenzyme Q10, which then goes on to pass the electrons off to complex 3. So if you're to look at a schematic of the electron transport chain and try to identify a bottleneck, it would be the availability of coenzyme Q10. So, and studies on oxidative stress have actually pretty much confirmed that, because the first of all, I should also mention that endogenous free radical production is considered the biggest factor in mitochondrial health. So the free radicals that are generated within our mitochondria. But more specifically, complex 1 is the number one site of free radical production in our body. And that's because if you don't have enough CoQ10, those electrons are entering complex 1, but complex 1 has nowhere to pass its electrons off to. So just like, a train, and I use this analogy in my book, you can think of each complex as a train station, and each train station can only have one train there at a time. The next train can only arrive if the previous train left. And what ends up happening is if that train doesn't leave, the next one comes in and then creates a collision or an accident. And that's very similar to how things work in the electron transport chain. If there's not enough CoQ10 to accept that electron from complex 1, well, that complex 1 is already occupied by an electron, and when another one tries to come in, you're going to create this collision, and those electrons are going to spill out and create those damaging free radicals. So CoQ10 is absolutely one of my favorite ones, and it's interesting because this is where my interest in mitochondria really came into play, because I was consulting at one point for a company that did significant business in coenzyme Q10 supplements, and they had a particularly absorbable form of coenzyme Q10, and this is one of the limiting factors in its therapeutic potential, is how well absorbed CoQ10 is. So this company did well because it had a product that was well absorbed, and it was used in hospitals, et cetera. And this was at a time where we started to realize that age-related female infertility was mainly due to mitochondria that were starting to fall apart. And studies in rats started to show that by giving coenzyme Q10 to these aged rats, they became fertile again. So a number of different fertility clinics, at least in Canada, started to use coenzyme Q10. So I was invited to do a presentation for their doctors and nurses to help explain why they need to be recommending CoQ10 to their patients. So it all boils down to, it all started with CoQ10. But what's interesting, again, because it's a bottleneck, it appears that when it comes to CoQ10, you want to have an excess. You want to make sure that you have a lot of CoQ10 laying around there and ready to accept an electron from complex 1 and complex 2, as opposed to, just a few where it's running back and forth from the different complexes, trying to shuttle electrons back and forth. And that's where problems can start, because if it's not fast enough or it fumbles an electron, again, you're going to create those damaging free radicals. So definitely CoQ10 is very important for anyone that is looking to use supplements for mitochondrial health.
So you'd say that would be like a primary starter supplement?
Yes. Yeah, and I think for most people, if you're in your teens or even in your 20s, probably not, unless you have a diagnosed CoQ10 deficiency. It's probably not something that you really need to take, just like I said, because our bodies actually produce enough of it. But starting in our late 20s, early 30s, that's when we start to see, a slow decline in our CoQ10 levels. And so, by the time you're in your 30s, again, if you're concerned about mitochondrial health, and I think everyone should be, that's probably the best time to start as a healthy individual.
And so it is something that you would say you would take every day, and you can do it chronically. You can do it for a long term. There's no problems with doing. You're not going to sort of deplete your own body's ability to make CoQ10.
No, and so now one of the things I'll mention is that the vast majority of the studies that I'm aware of that use CoQ10 were all done on a sick population. So I'm going to be extrapolating a little bit here to a healthy population, but two things. You do have to take it daily, because if you don't, then your body is your body's not producing enough on its own. So that supplemental CoQ10, when you stop taking it, that level of CoQ10 will slowly start to decrease back towards baseline. So you're going to essentially lose the benefit of taking CoQ10 if you stop taking it. To answer your second question, though, are you going to is your body going to adapt by making less CoQ10 on its own? And that doesn't appear to be the case. Long-term studies with congestive heart failure patients, and most clinical studies on CoQ10, what they do is they take baseline levels, blood levels, and then, during the study, they take levels again, and you see an increase in CoQ10 levels according to supplementation. And then at the end of the study, after the study is done, some of them stop taking CoQ10, and you see this slow decline back to base level. But what's interesting is that base is no lower than the starting point. So that would indicate to us that your body isn't making less because of supplementation. It just always had that base level of production. You are just able to increase the blood levels with supplementation. So again, if you're looking to get the benefit of CoQ10, the idea would be to take it on a continual basis.
Okay, and any tips then, just because I'll leave it at this, CoQ10, and anyone can get your book and get all the other supplements.
Sure.
But just so with CoQ10, is there a clinical level that gets the best benefits? So X amount of milligrams per day, or, would you say there's a difference between a petite female and a large male that you would prescribe?
Yeah. So this is where it becomes, again, going back to the N of 1, it really becomes an individual thing, because and again, I'm going to use data from cardiovascular patients and more specific congestive heart failure patients. But the idea is to get blood levels to at least 2.5 micrograms per mil. Now, in some cases, you want to, the best results we're seeing with blood levels at 3.5 micrograms per mil. But, I think the idea is to try to get it, at least, again, for congestive heart failure patients, to at least that 2.5 micrograms per mil level. Now, that is going to depend, the dose that's needed to get to that point is going to vary dramatically from person to person. So I've seen studies where a person had great response and was able to reach that level with, say, 150 milligrams of CoQ10 per day. Others needed to take 600 milligrams per day. So it really is one of those individual things. The problem with this particular situation, though, is very few labs, at least in North America, I don't know how it is in the UK, but in North America, it's not a blood level testing for blood levels of CoQ10 is not a common thing. And out of the few labs that do it, apparently it's quite expensive. You're looking at about $150 per test. So you take a blood level 1 week, and then you take a certain dose, and you go back in 2 weeks to see if that was the right dose. And if not, you increase the dose, come back 2 weeks later. Every time you take a blood test, it's $150, which can add up pretty quickly. So not only the cost, but the availability of that is pretty much rules that out as a way to move forward for most people. So the second best way is what we call symptom management. So what that means is, we, as an example, just looking at high blood pressure. If you have high blood pressure, and CoQ10 has been shown to benefit high blood pressure, you can start with, say, 100 milligrams. And in 2 weeks, if your blood pressure hasn't come down, you can boost it up to 200 milligrams. And, after a couple of weeks, if it still hasn't come down, you can boost it to 300 milligrams. So the idea is to continue to increase the dose until you see a therapeutic response. Now, this has its own problems, because nothing has 100% success rate, whether you're talking drugs, supplements, or even surgery. So there are going to be a few people that take this approach and will continue to take higher and higher doses, but not see the benefit. So that is one of the reasons why we typically just work within dosage ranges. So again, I'm referring to congestive heart failure patients, but it seems like the therapeutic dose for the vast majority of the individuals, and mind you, it doesn't capture everyone, but the majority of the individuals should be able to get by with anywhere between 100 to 600 milligrams per day. Even that is a significant range. But then if you look at conditions like Parkinson's, where coenzyme Q10 has been studied for as well, some individuals are using 3,000 milligrams per day. So it's not only looking at the individual, but it's also looking at the condition you're looking to treat. So when it comes to, just a healthy individual looking to take CoQ10 preventatively, what dose would that be? I'd probably say it's on the lower end of that congestive heart failure range. So you're looking at 100 to 200 milligrams per day. I think that should be okay. But again, all these studies have really been done on sick individuals. So that's really where what we have to look at as our starting point. But you could logically assume that being healthy, you probably don't need to take as much as someone that absolutely needs it.
And there's no toxicity, no sort of side effects from taking it.
Yeah, again, when you look at studies based on Parkinson's disease patients that were taking, 3,000 milligrams per day, and actually one study used 3,600 milligrams per day. So these are massive amounts. There were no toxicity. There was, in one study, a few individuals dropped out because they had GI upset, and that was really attributed just to the large dose. But in terms of actual toxicity, it wasn't shown to have any toxic effects. So it's one of those supplements that appears to be quite safe, even in large doses. But again, it's not necessarily a cheap product to begin with, especially if you're buying something that's clinically researched and shown to actually be absorbed. So, my take on anything, but especially expensive supplements like CoQ10 is the minimum needed is where to fall.
Okay, great. Well, I know we're a bit tight for time and you need to travel, but I think you've revealed so many good actionable tips about how to boost someone's energy today. And as you said, exercise is number one. Just move your body. Mm-hmm. That's the most powerful thing you can do. That your diet does influence it, and there's so many other factors that we touched on, and your book has even more in this. So I'll put a link to your book in the show notes and everything. But there any particular way that anyone could follow you or keep in touch with you? Links that I can put in the show notes for listeners?
Sure. Yeah. I mean, my author website, which I kind of started after getting the book on the way, is just LeeKnow. So LeeKnow.com. I'm on Twitter, which is LeeKnow 3D. So LeeKnow 3D. So those are probably the best ways to follow me and reach me if you need to contact.
Okay, fantastic. I'll put those in the show notes for listeners.
Awesome.
Lee, thank you so much for your time today, and thank you so much for sharing all that awesome information.
Thank you for having me, and I had a good time. Thanks, Gary.